In the archipelagos of South Sulawesi, the seasonal surge of the ocean has become a physical weight against the land. For communities on these low-lying islands, the global rise in sea levels is measured in the inches of saltwater reaching their front doors. Life here is interwoven with the coastline. These families rely on the immediate network of shallow water ponds for their daily protein and economic survival. Yet even in these isolated waters, the symptoms of globalized consumption are present. Traditional wooden fishing boats now sit in a thickening layer of imported plastic waste, carried here by the same global currents warming the planet. These communities bear the immediate physical brunt of a systemic failure occurring thousands of miles away, a crisis driven by industrial processes they did not build. When researchers profiled local junior high students, they found a baseline of moderate ecological awareness. The students could identify environmental terms on a test, but their understanding of how those concepts functioned was fragmented. Diagnostic interviews revealed that students viewed concepts like carbon emissions as abstract classroom definitions. Because these textbook models are based on Western industrial cities, students struggled to see the science operating within their own island context. This gap between rote memorization and lived reality creates a disconnect in behavior. A student may understand the greenhouse effect in theory, yet continue daily consumption habits that contribute to the very waste washing up on their shores. Making global threats actionable at the grassroots level requires a curriculum that translates invisible atmospheric data into the physical space of the community. The intervention used to bridge this gap is Ethno-STEM, a framework integrating indigenous knowledge and cultural traditions with modern scientific analysis and problem-solving. In South Sulawesi, this took the form of the Local Food Carbon Footprint Project. Educators set aside global climate projections and focus students' analytical tools on their own dinner plates. The project uses traditional food consumption as a rigorous lens for inquiry. Students trace meal ingredients back through local markets and cultural fishing practices. Using local culture as the primary diagnostic tool allows students to apply Western-centric scientific concepts to the resources and logistics they navigate every day. To prove how geography affects the atmosphere, students compare two meals. Choice A is an imported non-local meal, and Choice B is a traditional South Sulawesi dish. Tracking the imported meal supply chain reveals a journey spanning oceans. Ingredients require cargo ships, flights, and trucking to reach this island market. Each mile burns fossil fuels. Students convert these geographical distances into a measurable tonnage of carbon emissions, making the atmospheric cost visible. Choice B follows a direct, local supply chain. The ingredients are harvested from the immediate coastal waters and surrounding land, requiring almost zero mechanical transit. The data visualization shows the difference in scale. The massive carbon footprint of the imported meal stands in stark contrast to the minimal emissions generated by the local, culturally familiar food. This calculation removes the abstraction from the climate crisis. It shows that personal food choices are not ecologically neutral, but are instead direct links to global emissions. The carbon footprint is no longer a concept from a textbook. It is a measurable attribute of the student's own plate. This analytical process marks a transition in the student's ecological awareness. They move from the cognitive memorization of facts toward what researchers call affective concern, a personal sense of responsibility for their environment. When students develop this emotional connection to the data, they identify situational opportunities to act. They begin adjusting their daily consumption habits, favoring local resources to lower their personal environmental impact. By centering the lesson on controllable, hyper-local actions, the framework helps students avoid the paralysis of global climate anxiety. They focus on the variables within their own reach. Environmental literacy is realized when scientific data successfully informs the daily decision-making of the individual. This model reframes indigenous knowledge as a scientifically sound blueprint for sustainability. These traditional practices are not just heritage, they are adaptive mechanisms for maintaining ecological balance in the 21st century. The success of the South Sulawesi project demonstrates that complex science is most effective when it is grounded in the student's lived reality, rather than being treated as an imported concept. The methodology is scalable. Any community can utilize its own unique cultural traditions to analyze and address international crises on a local level. Meaningful climate action begins with communities that are scientifically informed and culturally empowered to make sustainable choices today.